Okay, everybody. Now let's talk about this linked stack, the implementation of linked stack. Okay, we discussed linear node in the previous video, so you understand how we came up with this implementation. Hopefully you understand all that. So let's look at how we can understand linked stack, how to implement that. Okay. So first of all, in my project, I have 3 folders. I have one that is stack. It has the array stack. That's the chapter 3 stack. And now we are implementing the linked stack. And linked stack will implement this stack interface. Okay, so, okay. To implement this linked stack, if you think about it, for a stack, once again, we only need one reference variable, one point. That's both the entry and the exit, because we can only access and remove from the top. So we declare this one variable, top. And a linked stack is made of linear nodes, right? So the top's reference variable's type is linear node. And because we don't know what it will be, so we use this reference, this generic type. And this is the same thing. You understand this from the array stack already, right? The T. So we have that variable that is referencing the top. And then we also need to know how many elements, how many linear nodes are on the stack. So we maintain this count. Those are the only 2 variables we need for this linked stack. If you remember, for array stack, what do we have to maintain? We have to maintain the top position. That's the entry point and exit point. And we have to use this internal data structure array, right? So our internal data structure for array stack is an array, and we maintain this top, which functions as the entry point and exit point. It also functions as the number of elements. With linked stack, because our internal structure is really linear nodes, and the client program does not know that. So this is our internal structure. We don't have an array. It's just this node, that's the top, okay, and the count. So this is the constructor. When you don't have anything, it's empty, then the top node is null. When it's null, what does that mean? That means these are all null, right? There is no element, there is no next element, so it's null. Okay, your top is null, right? That's the linear node. This is the linear node, everybody. It's not the array index. Remember that, okay? And here, this is the overloaded constructor that accepts a generic element. And when you have a generic element, now we will increment count. That means you have an element, but our stack is made of linear nodes. It's not made of generic type. So what do we have to do first? We have to make a linear node out of this generic element. Okay, we have to package it, wrap it around, make it into a package, make it into a linear node. So if you look at our linear node class here, right, it accepts an element, and that will be the element in the linear node. And next, it's still null because we don't know where it will point to. Okay, so that's what happens here. We make out of this element, we make it into a linear node so that we can put it onto the stack. And that's what that is doing. We are putting it onto the stack. We designate it as the top. When we say we put it onto the stack, we simply designate it as the top. So if you, let me do this, okay? So if you say, I have a stack, I have an element, so you are given an element, right? And here in your linked stack constructor, you will package that element, okay? That's your element. And then you will have next, which is null. So next is pointing to nothing, it's null. And this is pointing to the actual element. Okay, whatever that element is, it's pointing to that element. So now you have this linear node on your stack. Okay, so what do? You designate this as your top. And remember, what is top? Top, once again, it's not an index. It is a linear node. Okay, so that's what that is, right? And you increment count. So this statement can be anywhere. It can be here. This makes more sense, actually. So that is the two constructors. Okay, now let's talk about this push. So push, suppose, okay, suppose you have an element here. You have an element and you want to put it onto the stack. So what do you have to think? How many scenarios are there if you want to put this onto the stack? There are two scenarios. One is your stack is empty. There is nothing, it's empty. Another scenario is that you have at least one element. And if you have one element, it doesn't matter anymore. You might have two, you might have three. So two scenarios, once again. One is the stack is empty. One is your stack is not empty. Why is that important? If the stack is empty, then this will be the top. If the stack is not empty, you need to connect this. If it's not empty, what do you have to do? This will be the top, but before you make it to be the top, you have to set it, you have to connect it to this one first, and then designate it as the top, right? So that's why we need to differentiate between whether the stack is empty or not. So here is this. And first we need to make it into a linear node. No matter what, we make it into a linear node. And we test if it's empty. If it's empty, this will be our top, okay? So that's what this is. If it's empty, then it will be the top. If it's not empty, what do? We will say, we will set this node next to be top. That's basically what this is doing, okay? We will set next to point to this current top. So currently, this is the top. Okay, we connect them first, and then we assign this to be the top. If it's empty, we will simply say, okay, now you are the top. That's easy, right? But if it's not, we need to do the connection first, and then reassign this node to be the top. That's what this is doing. Okay, and no matter what, you need to increment count plus plus. Because when it's empty, your count is 0, right? This is the linked stack constructor. And if your linked stack has at least one element, then your count is 1. So no matter what, you increment your count. So that's the two scenarios. Another way to implement this, I will make it a little bit more efficient, because if you look at this, okay, top is equal to node. Top is equal to node. That means no matter what, you assign this node to be the top node, right? This newly pushed, last pushed element should be the top, no matter what. So we are repeating this statement here. So how do we make it more professional? How do we do that? I would do this. You can do this. If, okay, count is not 0, because if it's not 0, we have a specific statement to do. If it is 0, we do this. And even if it's not 0, we still do this. So this is the common statement that in either scenario you have to execute. Then only when it's not 0, we have a specific statement to execute. So I will say if it's not 0, then I will do node.set next top, right? So you can do this. And then no matter what, your top should be this node. That is this statement because it executes in either situation. So you can really make it more succinct using this syntax. Okay, if count is not equal to 0, you make the current nodes next to be the top, connect them, and then no matter what, you will execute these two statements. Okay, that's another way to do it. That's the push method. Now let's talk about the pop method. Okay, pop. We throw the exception, and I imported the stack exception. And if count is 0, that means the stack is empty. We throw this exception. You understand that? This is very similar to the array stack, right? For push, you do that. For pop, what did we do? Did we do the throw exception? I thought we did, but this might be a different implementation for me. Okay, I think the one I showed you, we did. Okay, yeah, this is one. Let me see this one. This is the one I showed you. I did this one. This one shows the exception. Yeah, okay. So if it's empty, you throw that exception, right? So that is how you implement the array stack, okay? Now, with this linked stack, you understand that? And this is the same. You do the element, you assign the element to a temporary variable of generic type. And this top.get element, remember top is a linear node. And when you say get element, what does it give you? It gives you the generic element, right? Element is a generic type. So when you do get element, it returns you the element, not the linear node, but this linear node's element inside it, that part. So you get that element, you assign it to a temp variable first, and then top is equal to top.getNext. What does that do? Okay, so if you have, I explained this that yesterday, I mean in the previous video, if you have two, right, that means this one is here. Okay, I will just do it here. So now this is the top. This is not top anymore. And this is connected to this one through the pointer, right? So if you need to pop this one, you get the element first, assign it to a temp. So now you are not worried of losing this linear node anymore because you already get the juice, the succulent part, or I'm thinking of oyster actually. Okay, you already got the substance into a temporary variable. And then you still have another part that's linking to this, right? So what you do now is, because you want to get rid of this one, so you will say my new top will be the one that's being pointed to by the current top's linear node, reference variable next. So my new top will be the one below the current top. And how do you get to the one below the current top? You use tops get next, right? Tops get next will give you this linear node. So that's how you get that, okay? And that's why here you say top is equal to top.getNext. It will give you the next element. And then you decrement count. You understand that? And finally, we return temp. That's how you implement these two methods. Let's see, the push and the pop. Okay, and what do we do? What do you do next? You will implement the peek method, which is very, very similar to the pop method. You already know that, right? Except you don't have to remove it. You are just looking at it. And then you will increment the, oh, I already implemented, didn't I? Okay. So, but these are really, really simple implementations. The most complicated one is this public toString. Okay, for this one, you really have to think. Here are the several points you need to think. I wrote them down so that I don't forget to tell you. Okay, make sure when you test it, make sure you call the toString method twice, so that after you call it the first time, it works, it printed out all the elements, and then you call it twice, a second time, it should print out all the elements again. If it says it's empty, that means your implementation is wrong. Okay, so make sure you test it twice to make sure it works. That's one. The second one is do not touch count, okay, because you need to definitely use a loop to print out, to return a string, concatenate all of them. Do not touch count, because if you touch it, then count is decremented or incremented, then your final count will change. So do not touch that variable. Instead, use a temporary local variable, assign count to it, and use that to make your loop work. That's a second suggestion. A third suggestion is remember, not suggestion, but a reminder. Remember, your stack should come out from top to bottom. So when you print, the first element should be the top one. Okay, the last one in the stack should be the bottom one. So the first one should be the top one. Make sure that's the sequence you are printing, you are returning the string. Okay, that's the third one. The fourth one, very important one, I think I mentioned this in your previous classes. Use the system.out.println to debug your problem. So if you have a problem, for example, it says a null pointer. What does that mean? That means your pointer is not pointing to anything. It's null. There is no element in it. How do you debug that? Print out the elements and see what it is and see what the previous one is. Okay. And if the loop goes one more time, print out the loop variable to see what it is. So you always use the system.out.println or print to debug. That's a very, very effective debugging method. You can use the debugger, but I find that it's more work than simply use the system.out.println. Insert it into your implementation and see what is going on, because that will show you what is going on. If your loop is wrong, insert that statement into your loop. If the element is wrong, insert it into right before, after your statement and see what is going on, right? That's a good debugging method. Those are the four pieces of advice. And afterwards, make sure you delete them. Don't leave them in your code. When you submit to me, you need to delete them. That is it, everybody. That's the LinkedStack class. I will do another video for the driver. Okay, I'm going to stop here. How do I stop? Did I?